friends, welcome to video lecture on engineering mechanics. In the today's session, we'll learn about the beams topic. So let's start beams. Beams are the structural members that are subjected to external forces and moments. Okay. So if you take an example of any building, okay, so might be you have seen the beams and a column. Okay. So here, if I take the example building, okay. So what are the ceiling portion available here? For that, the support is given with the help of the beams as well as columns. Okay, so column just we're doing the 2D picture. So you just see here the use of this one is the thing, but to carry only external loads and moments means here when actually external load is acting here. Okay, that is subjected to a rotational motion available in the any given portion. Okay, so that is subjected to external loads or external forces as well as moments. Okay, so let us we see the types of the beams. Now we will see the types of beams. Okay, so here the list of the type of beam is in front of you. First one is the cantilever beam. So the diagram for the same is drawn here in this column, and here see the information about the same. Okay, so what's about the cantilever beam? So if you just see here the diagram in front of you, one end of the beam, okay, in this way this indicates the beam, so other end is here fixed. So here one end of the beam is fixed and other end is free. Here the other end is free, with us. Okay, so if you just say this is the actually example of a cantilever beam. Let us assume that the pin is fixed from one end and here is the free end on which we can apply certain load here. Okay, now what's about the next one? Simply supported beam. So the beam is placed on the two supports or knife edges. So here if you just see the beam is placed on the two supports. One support is given from the left end and another support is given from the right end. So this is known as a roller support. We'll just see the information regarding this support, okay, in the coming part. Okay, so the beam is placed on the two supports or knife edges. Knife edges means here the sharp edge, okay, on which the beam is placed. Okay, and after that, as per our earlier discussion, the beam is used to carry the external forces and moments. Okay, so what's about the next one? Overhanging beam. So if you just see the some of the portion of this beam is extended over the support. So the two supports are given here. One is given from this end, other is given here. Somewhere here the first load is acting on that particular beam, and if you just see this load is acting over the extended portion of this beam. Okay, so this is known as overhanging beam. Okay, so this portion is extended beyond this support. That's why the name given for this one as overhanging beam. Next one, fixed beam. You just see the fixed beam in front of you. Both the supports are fixed. You just see this support as well as this support is fixed. Okay, and on which the load, external load is acting. Okay, so if you just see whatever the beam portion goes inside of the wall. Okay, this is the best example. Okay, now whatever the load is acting on that particular beam. Okay, just indicate with the help of this one W, and this portion goes inside the wall surface. Okay, this is the example with the beam, fixed beam. Okay, so let us discuss about the types of loads. The first one is the point load or concentrated load. Now see the meaning for the point load or concentrated load. For that, if you just consider the beam like this one, so this load is acting at the particular point. Okay, so this is known as point load or concentrated load. This load is particularly acting at a point on the beam. This load is particularly acting at a point beam. This is known as point load or concentrated. Okay. Now we'll say the uniformly distributed load. Uniformly distributed load. Short, you can just say the UDL, uniformly distributed load. Discuss this with the help of example. Uniformly distributed load, that let us assume that is supported beam with us like this one, and uniformly distributed load, okay, that can be indicated of this. Then you see the load acting on this one is uniformly distributed. That can be by single load like this. Another way, the same thing from here would be with us. Okay. Uniformly distributed load on but the particular length which that load is can replace this load, or effective load of this one is nothing but here W equals to the load acting. Just see how that actually load is in the effective load. So here also this indicates W. So effective load W can be calculated in this way. Effective load nothing but small w divided by L. Distance by 2 from the either ends. The uniformly distributed load over the length of beam. Here just see load is formally per the length of beam of. So this is the case of uniformly distributed load. Okay. Now if you just see here, this is the uniformly distributed load can be integrated in this way also and also. Now while solving the problems on the same topic, you can just convert this uniformly distributed load into point load. So in this way, so whatever the effective load with us, that is a W, okay, is nothing but the W multiplied by L. This indicates the W per meter. So whatever the length is given, length given here, you have to multiply by that length with this value given, so that we can get the value for that point load. And the location of that point load is from half distance of entire length given from both the end, either from this end or either from this end. This you can get the effective load. So let us see the next type of the load. This third one, uniformly varying load, can be shown in this way also. Uniformly varying load means L, like this one. Okay. Now let us see with the help of one diagram so that you can get it clearly. For that, let's suppose once again this supported beam with us, okay, which this portion the load is uniformly varying in this span. So this indicates the of every force at that particular point. Now if you look towards this load is uniformly varying over this surface. So this load is acting on this entire length L. So effective load can be shown this way. W will acts at a distance of L by 3 from this end, L by 3 from this end, 2/3 of L from this end. Okay. So in short, from the front end, location of this point load is at a distance of L by 3 from this one front end, and from the tail end, location of this load is at a distance of 2 by 3 into L. Okay. So what's about the effective load that can be seen with help of this relation, or before that just see the intensity of load. Intensity means here the value of the load is varying along the length of the beam. So just say how to get the effective load. So effective load W is nothing but, in short, area of this triangle. So what's about the area of triangle? 1/2 base multiplied by height. So in this case, if you just say 1/2 base with us L, height with us in terms of W. In this way, you can get the effective load. 1/2 base means here L, or simply you can just write in this way WL by 2. So that will add L by 3 from this end. Let's say this one is the W end. Just say the W end. Here we'll just say the O end. Okay. Acting from W end are 2 by 3 into L from O end. I hope there's three types of the load clear to you. First one is nothing but the point or concentrated load. Next one is nothing but the uniformly distributed load. Next one is nothing but the uniformly varying load. So if you just say this load is uniformly varying on this particular length. So I can get the effective length for the same. So effective length is nothing but here, in short, the area of this one. What's about the area? Area you can get in terms of 1/2 base with us in terms of L, and height with us terms of the W. Okay, no doubt here W per meter is written, but whatever the value given, just consider that value as it is 1/2 multiplied by L into W. So I can get the effective load WL by 2. So where is the location of this one? At a distance of L by 3 from this W end, and at a distance of 2 by 3 2 by 3 into L from this O end. Now we'll move towards types of supports. Now, first one, nothing but the frictionless support. So just see here the frictionless support with us. So whenever if I consider any actually a roller or the spear or rolling on the flat surface, okay, so without friction, okay, no any resistance comes when this will start moving to this direction or this direction. Okay, so frictionless actually a motion of that particular roller takes place on this flat surface. Then how to draw the freeboard diagram for the same? So whatever the weight of this one that will act in the downward direction, at the same time the normal reaction will come from the bottom of this one. Weight of this one will just consider in terms of W. Whatever the weight of this one, the same amount of the reaction comes from the bottom of this one. So the reaction acts normal the surface at point of contact. And if you just see the point of contact of this one with us here, so the normal reaction will comes in the opposite direction of that whatever the self weight of the particular this one roller or that particular sphere we are considered. Okay, this is the case of the frictionless support. So next one is nothing but the roller and knife support. Knife support. For that, if I consider the beam, that support is given from one end to this beam, the help of a roller in this way, and just see from the other end also we can just show a roller. Okay, the meaning for this one is this one and this one is same. We are just showing that support this way, nothing but the knife support. Okay, and if you just see just over here the rollers, okay, case of a roller support. Okay, what's about this one? But the roller support, this also indicates the roller support. And while drawing the free ball diagram for the same, you can just show this way. Beam with us here this way. Support come from this one. Just show that support help of this reaction this way. RA indicate the reaction at this spot, and if you just see, if I just consider the B point here, A point here, this indicate the reaction at point. It support restrict of the normal in surface. Now just see the next one. What is the hinge support? For that, consider the system. Okay? So here is the A point with us, here is the B point with us. Now while drawing keyboard diagram for this case, just draw the beam. Okay, look towards the support. Here is the support. Okay, so reaction this spot like this one. Now one more important thing related with this, all the types of the support. Here the reaction comes where the motion is locked. That point is very important one. So if you just see the in case of the hinge support, just see the previous one. We have discussed the first one is the about the frictionless support. Okay. So in case of that frictionless support, if you just see here the motion of this particular roller is restricted the vertically upward direction and downward direction because the obstacle is here. Okay, that's why you can get the reaction on that particular roller from the bottom of this one. Why bottom of this one? Because the restrictions comes towards the motion of this one in downward direction. Downward direction or upward direction. That's why the one reaction will come here. Now if you just see the next case we have discussed is nothing but the roller support and native support. Here in this case also the motion of this one will restricted in upward direction and downward direction because the support is given by that roller. A roller actually allows for the motion of this one beam towards this left side towards the right side. Okay, hence only the reaction will come from the bottom of this one. That's why here the RA reaction is shown. What's about the hinge support? So in case of hinge support, the motion of this beam is restricted here, restricted in horizontal direction as well as in vertical direction. That's why the one reaction will come here, horizontal reaction will come here. Okay, so horizontal motion of this one is blocked. Here the hinge support is given. Okay, means this will just move in this way, but this will not move in either towards the horizontal direction or towards the vertical direction. Okay, in this way towards the vertical direction or towards the horizontal direction. That's why the reaction comes from horizontal direction as well as from the vertical direction. Okay, here that's why we are considered as for the horizontal compound of this one I'll just say HA, and vertical compound of this one, vertical motion is blocked here. That's why I'll just consider this one is nothing but the VA. The resultant of this one will come somewhere here, okay, but the RA. So as per our previous discussion for the roller case, a single support will come. Okay, this motion is blocked. No any vertical motion of this beam takes place. Okay, here at this spot, no doubt the horizontal motion will come here. That's why only restriction occurs for the motion of this beam in vertical direction. That's why only single reaction is shown here. Okay, this is the next one, next case, the hinge support. Okay, now next one is nothing but here built-in support or fixed support. The next type is nothing but built support or fixed support. For that, let's consider the diagram for station. So this is nothing but the fixed support. Okay. So already you have seen the example with the cantilever beam. Some of the portion of this one goes inside of the wall surface. This is nothing but the built-in support. Okay, built means here that it goes inside of that wall surface. Okay, wall portion. Okay, so this becomes a fixed one, and other end is free here. Okay, when I put the load here, let's consider this is nothing but the A end. This is nothing but the B end. Now see how the reactions will come here. Now if we focus on this portion, A spot, the reaction at this spot A are nothing but, now if we just see here, if you just focus only on this A spot, it will not allow us to move this beam towards the right side. Right side means here we can get one reaction in horizontal direction, that is HA. This will not allows, will not this one, this support will not allows for the movement of this beam in upward direction. That's why here the reaction will come. This will not allow to move in this way. This way means here one more, actually the movement will comes into picture. Okay, means when we apply certain load here, the tendency of this beam to react this one in opposite direction of this. Okay, means here the one more actually reaction comes into picture. What's about that reaction? But the movement about this point A. Now if you just see, if the end A of the beam AB is fixed in concrete wall as shown in this figure, it will restrict the motion of the beam in horizontal direction and in vertical direction. Also it will restrict the rotational motion. It will restrict the rotational motion. Hence the two reactions, one reaction couple is exerted. This is the free body diagram for this particular. I hope that the types of the supports showed you. Let us will see one problem on the same topic. A simply supported beam of length 6 meter is carrying a point load of 10 Newton at its center. Determine the support reactions. So for that, the system is given in this way. So first of all, you have to draw the free body diagram. So for the answer, you have to draw the free body diagram of the given beam as, for that just draw the free body diagram in this way. Now think over this one. What's about this one? This is nothing but the hinge support. So in case of the hinge support, the two reactions will come. Remember, this is the hinge support. Okay, in case of the hinge support, this motion and this motion is restricted. That's why the two reactions will come. That is one reaction along the horizontal direction, another in vertical direction, and the resultant of the same will come somewhere here. Okay, in this way. What's about from the another side? Here the roller support with us. For the roller support, the only single reaction will come. What's about the this load? So you have to show as it is. My target is to get the value for this one RA and RB. This indicate the support reactions. Just 3 meter this side from this side. In this way, first of all, you have to draw the free body diagram of the given system. Now, by using the conditions of equilibrium, now apply the conditions of equilibrium by using conditions of equilibrium. Now, what's about the conditions of equilibrium? So remember, in case of the any general force system, already I have seen case of the general force system, the three conditions of equilibrium with us. Summation of f of x equal to 0, summation of f of y equals to 0, and next one is the moment about any point. Let's say here either a point or b point. I will just consider the a point must be equals to 0. The three conditions with us. Now in this case, if we just say no any force available with us along the horizontal direction, so what it indicate? Summation of f of x equal to 0 means what here? See here we have shown here the reaction horizontal direction. No any force with us apart from this one. The active force on this one beam is only 10 kilonewton that acts in vertical downward direction. Means here HA must be equals to 0. Because no any horizontal force with us, so HA must be equals to 0. Now move towards the next one. summation of f of y equals to 0 equals to. Now concentrate only on the vertical forces. What's about this one? VA with us. Okay. So for this VA, if you just see the horizontal force with us 0, means VA and this one, the effective reaction is nothing but the RA. This RA indicates the resultant of this HA and VA here. As the value for this HA is 0, means here VA must be equals to RA. VA must be equals to RA. I'll give the explanation of this one, how this RA will comes for this one, the VA after completion of this. So RA with us, okay, this one VA must be equals to RA. So initially just consider this one as VA as it is. So VA vertically in upward direction. For this also you need to consider the sign conventions. Okay? Already I have seen this one in first topic, that is under the system of covalent forces. Already I have seen this sign. The same sign convention here. Summation of all the vertical forces equals to 0 equals to. So the first force with us VA, next one with us vertically in the downward direction, consider this force as negative. Now the next force with us is magnitude RB with us vertically in upward direction, so consider this force as positive. What's about the next one? Therefore A plus this one RB, getting this way 0, equation number 1 for this one. Move towards the next equation, that is the moment about any point equals 0. Just consider this point and take the moment about that point. Now taking moment about point A. For that, just here, moment about point A of moment, summation of all the forces about this A point must be equals to 0 equals to. Now just we are consider the point A here, about which you have to take the moment of this force and this force. Why we are taking the moment here? Because we can get unknown terms easily. So here is the point about which you have to take the moment. So first force is here 10 kilonewton. You have to take the moment of this 10 kilonewton force about this one. Now what's about this force and this force? The line of action of this force and this one passes through this point. So the moment becomes 0 because the distance becomes 0. Okay. What's about this one 10 kilonewton? For that you need to consider that sign. Here you need positive, here consider as negative. What's about this one 10 kilonewton force with us? Turns about this point in clockwise direction in this way. So for clockwise give the minus sign, multiply by. So what's about the distance with us? 3 meter. Now next force is here RB. So tendency of this force to turn about this point in which direction? Anti-clockwise direction. For anti-clockwise give the plus sign, multiply by. What's about the distance between the line of action of this force and the point about which the moment is to be taken? 3 plus 3, 6 distance with us. Now easily you can solve this relation. What's about the RB? RB equals to this 10 multiplied by 3 goes towards the another side, divided by 6. The RB equals to how much? 5 kilonewton. Once we get the value for this one, RB, equation number 2 for this one, and substitute the same value in equation number 1. Equation number 1 is here. So what we get here? Therefore we can get the A plus RB means here 5. Here in this case here 10. Yes. So what we get here? We can get the 5 equals to 10. So for this VA we can get the 10 minus 5 kilonewton. What's about this VA? So initially this HA with us 0. So resultant of the same is here RA. So I can get that RA is nothing but root of HA square plus VA square. So what's about the HA with us 0 plus what's about the VA? So VA with us 5 kilonewton, 5 square of this one. So what do we get here? RA equals to what's about here RA equals to 5 kilonewton. That's why here actually whatever the value for this one, value we have considered for this one, okay, whenever the value for this one HA becomes 0 means VA is nothing but the RA. What's about RA here? We can get the 5 kilonewton. What's about the VA? We can 5 kilonewton. Okay, the same value with us. That's why RA equals to A. So as far as the question asked here, at last, this right here, sir, answer. RA equals to 5 kilonewton and RB equals to 5 kilonewton. I hope theory related with this beam topic as well as one numerical on the same topic cleared you. Thank you.